has been a long day filled with technical issues and policy insights. I promise I will be very short and brief. Thank you so much for the kind invitation. And just a small reminder about Paris Agreement that all parties committed to declare their own mitigation plan, what we call nationally determined contribution. Unconditional NDCs when a country uses its own resources and capabilities. And also conditional when countries need some kind of international support or other conditions are met. And ambitions of NDC target are far from achieving 1.5 target. We already reached now 1.3. Methane is a powerful greenhouse gas. When we speak about global warming potential, 1 ton of CH4 equal to 29.8 ton of CO2 equivalent. This is over 100 years, and over 20 years, it's almost 82.5 ton of CO2, which means that methane is responsible for almost 40% of our emission within the coming 20 years. This graph shows us the methane emissions from different sources. Wetland come at the first, second agriculture, and energy sector is the third largest source of methane emission. Around 23%, this is a large share and also a big opportunity. And as we can see here, oil and gas sector account for around 14%. So methane emission occurring along all the value chain, starting from exploration, production, transport, refinery, transmission, and distribution. We can classify methane emission into two different categories: engineered or planned. This is dependent on the process, equipment choice, or safety reason. We call it vents. And unintentional, we refer to leaks. And also flare matter, as my colleague explained, and it depends on the combustion efficiency and volume and also weather. So each facility typically has hundreds of emission points, such as leaks, pneumatic devices, when gas used to power actuators and pump, maintenance, compressor as well, for example, root filling and seals, flare and tanks. They might be small points, but when we combine all of them together, it makes a big impact. So drivers for tackling methane emission, as we mentioned before, of NDC targets, and also pressures from international market. Calls for transparency like ESG mandatory reporting right now, also increasing for demand for low emission product, and most important that methane technologies, mitigation technologies now are available and cheap and very quick to implement. So each country should submit its own greenhouse gas national inventory using Tier 1 and Tier 2 and Tier 3. But estimates of methane emission vary a lot, and also magnitude of emission is very uncertain in many countries. We will deep dive in the 3 tiers right now. For example, Tier 1 methodology, we use emission factor, but it's not enough because countries are using different technologies and different equipment. Tier 2 methodology, country-specific emission factor should be developed, but the problem here is super emitter. Data provided by Environmental Defense Facility shows that 3% of the equipment might be responsible for over 60% of the emission in some cases. The ideal is Tier 3 methodology, detailed model, facility level data, and also direct measurement. So the best is combination of two different approaches. When we are targeting region or facility or process, we might use top-down approach. satellite data, or also airplane or drones. But this cannot target like small component or equipment. So in this case, we use bottom-up approach. When we use ground measurement like optical gas imaging and calibrated vent bag and so on. The combination between both approaches give us a better picture about our emission inventory. So examples of mitigation options, my colleagues already mentioned some of them, which prove this is the evidence it's easy to implement and applicable. Systematic and periodic leak detection and repair, rerouting methane for vents, replacement of high-emitting equipment by best available technologies, a procedure for minimizing emission during engineering, especially at the design phase, guidance to minimize emission during maintenance and operation, and continual improvement. For example, setting emission reduction management plan, setting a mitigation target, and also reporting mechanism. We have some barriers, but good news, we have also solutions. But the main important issue here that companies should commit more, and also government should act and collaborate. Okay, this graph shows us the marginal abatement cost curve for methane technologies in oil and gas sector. And as we can see here, globally, it's estimated that 40% of the methane emission could be implemented with no net cost, even some projects making savings. And also this graph shows us the classification of the spending required by region and also by company type. The focus here in North America, Euro-Asia, and Middle East, and as you can see, they didn't say Asia. So, and also it required 1 billion of spending for the oil and gas sector. As I guess it's around 2% from the revenue, so it's not a big deal. So policy development is the key. Mandatory leak detection and repair, LDAR system, technology standard, zero non-emergency flaring, and additional measures like emission pricing, financing mechanism, and MRV regimes. The International Energy Agency published a regulatory roadmap, 10 steps for policymakers. We can categorize them under 3 main pillars: understanding your setting, develop emission profile, and the nature of your industry, and then designing and developing your regulation, build regulatory capacity and engage stakeholders, and select the appropriate policy for implementation, and finally the implementation phase, and last not least should be periodically reviewed, because methane mitigation strategy should be systematic, like plan, do, check, act, timing cycle, and so on. In conclusion, methane abatement is not just a climate imperative, but also very strong strategic opportunity, economically and socially. And I would add collaboration is the key, especially when we speak about technology transfer, sharing the best practice, and also financial support. Thank you so much.
Thank you very much, Ibrahim. Any questions for Ibrahim?
Thank you. Really, this is very extensive agreement. Maybe this is very, it's not only for this presentation or for the insights that you have showed now, but as well for the other initiatives that were taken in the decarbonization journey across several companies and several issues. Maybe this will pave the way for tomorrow's discussions, especially that it seems a bit that most of the technologies are there, the financing is so easy. Most of the projects of the decarbonization that you talked about now and for the other colleagues, maybe they are on ground, it's very easy. Most of them will be without cost, as you mentioned, across the marginal abatement cost. But I think we are in a very big need for a harmonized policy and regulatory framework that will govern everything and will govern most of these projects. And maybe we will have tomorrow some comprehensive discussions regarding this issue, because unless we have these regulations on ground, maybe the EMGF during the last couple of years have developed several studies for this, and we have developed a very expensive harmonized policy and regulatory framework that includes the LDAR, fugitives and venting, flaring, and several marginal abatement options for the decarbonization for the companies, including the incentive options and different types of options that will incentivize this decarbonization. So this is not a comment, but maybe we are sure for a need for this, and I think tomorrow we will have some extensive discussions regarding this issue, because this is very crucial for implementing the decarbonization and most of these projects. Thank you.
Yeah, thank you so much for your insights. And the market is like dynamic. I will just answer this question by my past experience promoting energy efficiency 10 years ago here in Egypt and Middle East. No one was interested in the prices, and subsidized was like covering everything. No one cared about to improve energy because energy is cheap. Now the market dynamics change the equation. When we see that, as I mentioned, for example, ESG reporting, the company should reduce its own emission, and then they want to buy services with lower emissions. In this situation, oil and gas companies will for sure commit to reduce its own emission, like what Eni already did by many programs. So for sure, policy and regulation is a key, but also companies should start to prepare themselves for the future of that net zero and the green future. Thank you.
So, excuse me for this simple question. So when we say, for example, I'm going to sell the fuel gas used to electrify the processing facility by replacing it with a renewable source of energy like solar or wind. So I'm decarbonizing at that point A, but in the meantime, this fuel gas you saved increased your sales gas to point B at your customer, as if you are swapping away methane emissions from point A to point B. So I believe if the decarbonization initiatives for the energy companies, if not coupled by decarbonization initiatives at the areas of consumption like the industrial users, to my eyes, we are saving at one point and increasing emissions at other point. Correct me if I am wrong about this.
If I understood your question well, you might speaking about double accounting for greenhouse gas emission. For example, let's say we all know like scope 1, scope 2, scope 3. Scope 3 is speaking about the emission by your service. For example, your employee using a flight. In this situation, they're going to use the emission factor by employee, by trip, and maybe another person from another company use the same. Okay, but this is for scope 3, not for scope 1 or scope 2. But let me give you an example. When we speak here about replacing, for example, the actuators using to like control the flow of fluid or gas in the facility, and that actuator powered by the gas pressure itself. Now there is technology to replace that actuator by electronic one using solar power, right? So in this situation, we try to reduce already the flow inside the pneumatic system in the facility of the natural gas, and at the same time there is no flow, so there is no emission. So this is kind of immediately remove the dependency on the devices powered by natural gas with the solar energy. Is it fine, or we still have confusion? Okay.